Okay, so that's you.
Muted myself.
Ah, there we go.
Yeah, I muted myself so that, you know.
Well, I think we'll probably need audio from that camera.
True, because you're presenting from the desktop that doesn't have any.
Yeah,
I forgot about that.
There's no microphone on this machine, apparently.
Well, let me. I'll just be very, very quiet when you're presenting.
Is that going to reach?
It may. Except move my machine. I'll reach you. No.
What a wonderful jury rig setup.
You know, I was convinced that these machines, these desktop machines, are fairly reasonable, and I won't have to do like, oh, we don't have a driver. But that's what happens when you don't test the machine beforehand, and I didn't. Well, somebody told me that yeah, you can present because they have presented from here, but they apparently did not need a speaker, you know, a microphone and a webcam because they were not broadcasting. They were presenting locally, which I assumed, okay, fine, so just going to plug in the camera, it will work. You know what? I'm just going to type in Slack and everywhere else that.
So they know where we are.
Yeah. Your steps.
Hello.
Hello. Hi. Take a seat.
Thousands. How are you then?
Not bad,
Good,
yeah.
good, yeah.
We're running a little behind schedule.
Because nobody's showing up on the Google Hangout.
3 viewers.
Oh, okay, good.
No, I don't know whether that includes the one that's
Here.
the camera. We'll see.
I can only see you and me.
I've got 3 viewers.
Yeah. Okay. Excellent.
Well, I presume America isn't awake, is it?
No. No, America was asleep.
I got that last week. That was all about 2 and 3.
Oh wow.
I think you can download it online. I think it's online download.
Oh, see, that's the problem. They can't connect.
They can't connect.
Yeah.
There's 4 viewers now. I see the camera obviously as well.
So David says, we have all clicked on the link that was on the website for the retreat, and it appears to take us to a Google Hangout on air. which means we're watching video stream, but we can't interact. Is that what we're supposed to be doing?
Depends on how many you want. You can only have about 10 interacting, can't you?
Yeah, but they're less than 10, I think.
Yes. Yeah.
Q&A feature claims to be disabled. Chat feature. Okay, when you see a chat there, then people can jump on that. You can certainly see questions coming up. Have a look on your one and see it. You see the chat feature on there. Maybe go back to your broadcasting one, wherever that one's gone.
Let's close that. Right. There we go.
There's the chat feature. There it is. Oh, turn it up again. There we go. So that should be the chat feature. Okay. So with a bit of luck, that should enable some interaction.
I'm not going with that, so plug in.
Good plan.
See, I've just done a 5K run, you see, so that's why I'm late.
Right. 5 viewers apparently. See if anybody can see the chat window.
So how do I get on the internet?
Dave, so Greg says here, we don't we need a new link? I think we've on Google Hangout on Air.
Mm-hmm.
So yeah,
Maybe
okay, I'm
I
gonna
need to
get the
invite them
password
specifically. Let's see if I can invite Greg specifically, and then she's Greg Wilson. Okay.
Where is everybody then? Are they
Elsewhere, I think.
yes.
Let's see if I can find a Greg Wilson.
There's another one in the UK, isn't there? Or in London.
Yeah.
Once we're done with the technology, we're gonna get you some tea or coffee, but we need to sort this out first. That is at least going.
Now, is that the Greg Wilson? Which Greg Wilson are we looking at here? That one?
No, neither. But you should be able to like create a link that you can post, not share it. Just yeah, and then close.
Yeah, let's stick that in the chat and see if anybody can see that.
But they're not on it. They will need a new link in the Etherpad. If you can go to the Etherpad.
Right, okey-dokey. Which one is that? Aha, Etherpad. Yay.
Right, I'm online now. Good.
Right. Okay. Hang on, link. Let's see if we can get the rest in the call. Aha! In prison. Okay. That's looking a little more promising.
Well, I can see it as well. Shall I join in?
By all means.
It says live.
Yep, it should be.
It says live.
Window.
So it looks like I'm behind.
Right. The question is, can we hear anybody on this? I can hear them through your laptop.
And here.
Yeah.
Right, I'll go off there, because that's only going to confuse it.
Right.
Right, I'll go off there, because that's only going to confuse it.
And probably you can open the chat here so that you could, or chat there, whatever.
Got the
Yeah.
chat on this one.
On Etherpad, we're operating the Etherpad chat.
Right. Okay. So
Yeah,
forget
so
this
you can,
one's chat.
you can.
We'll just use the Etherpad chat on there.
Yeah.
Right.
Even look at his eyes.
Okay.
Can you open the, yeah, can you see the, okay.
Yeah,
So
that's
Greg says
fine.
if you could share the Etherpad. Yeah, sorry, screen. Yeah.
Yeah, is that the right one?
Yeah, that's the Etherpad.
Right. Can everybody actually see the the Etherpad on the screen share? Black screen. Okay.
Yeah, we all can see from Dave's screen share. Back screen.
Yep. No worries. Hang on a sec. Stop that. Screen share. Entire screen. That's the one.
I can see that.
Right. How about now? Hey, excellent.
Okay.
Right. So you still hear everything, but we can see the desktop.
All right, this should help you.
Well, basically I can
Yeah.
toggle between either that or...
Okay.
Yeah. That should be fun. Okay. So we've got audio, we've got video. Right. So, I guess in that case we may as well get started. Welcome to the ever so slightly delayed Software Carpentry Instructors Retreat, and this talk, making friends with Python 3. Just in case anybody can't see terribly well on the Hangout or wants to just follow along at home, you can go along to www.waveform.org.uk/presentations/py3friends.
It's very quiet.
Quiet, is it? Oh no, is that their problem or ours? I'm going to fix volume, sorry. Okay. Link in the Etherpad, not a problem. We can do that. Okay. So that should allow you guys to follow along on your own web browsers, which may be slightly easier for you. That's me. If anybody wants to contact me offline to have a chat about Python 2 and 3 migration, or wants to see some examples of code that works in both, that's my GitHub as well. So, on to Python 2 and 3. First of all, does anybody need convincing that migration to Python 3 is something they should be attempting either now or in the relatively near future? If no one needs convincing about that, we can skip this bit. Let's just see what happens on the chat. Does anybody need convincing? Okay, right. We're all thoroughly on board with the idea of Python 3. In that case, let's skip through some rather amusing slides. Just to give you an idea, I should just note from the Python 2.7 release notes, Python 2.7, this is from the release notes, so this is several years ago, currently expected to remain supported by the core development team until at least 2020. So the migration was never intended to be fast. It's a relatively slow burn thing, and there's no absolute need for you to jump onto the Python 3 interpreter right now. You can happily write Python 3, more or less idiomatic Python 3, and run it in the Python 2 interpreter if you're still relying on libraries that haven't been ported yet. But it is true that since the majority of libraries have now been ported to Python 3, the pace of migration has picked up quite a bit. So, given that we're all convinced that we'd like to write Python 3, how do we do this? There's several different ways. 2 to 3 is a tool that's provided with Python 2.7 that enables you to convert Python 2 code into Python 3 code. Personally, I'm not too fond of this particular approach. There are issues with it. The code that 2 to 3 outputs is not compatible with Python 2. So either this means that you need to migrate right away, which may not be an option if you're relying on libraries that rely on Python 2, or it means that you wind up effectively maintaining two code bases, your old 2 code base and the new 3 one derived by continually rerunning 2 to 3, which is horribly slow and occasionally falls over on the odd thing. So personally, I much prefer the idea of writing idiomatic Python 3 that's compatible with Python 2. How do we go about doing this? If you're on Python less than 2.7, if you're on 2.6, 2.5, etc., or God forbid anything truly ancient like 2.4, you've got a problem. You need to upgrade. The major reason for this is that Python 2.7 was intended to be the last of the 2 series, and therefore includes numerous things that enable it to be more compatible with Python 3 that are missing in Python 2.6 and before. Specifically for the academic community, this means if you're on Scientific Linux 6, that includes Python 2.6 as its default interpreter, and you probably want to go and persuade your site admins to upgrade to Scientific Linux 7. Or if you control it yourself, just do the upgrade yourself. Scientific Linux 7 now supports Python 2.7, so you'll be sorted from there on out. Scientific Linux 6 is still in support, and officially will be for several years, but it's worth noting that Python 2.6, its default interpreter, has been out of support for 2 years now. So you've had no patches from the core teams, for those 2 years, unless presumably Red Hat are hopefully backporting stuff from 2.7. So that's the story if you're on less than 2.7. What if you're on greater than or equal to 2.7? Well, in that case, you're pretty much good to go. So let's see how we go about doing this. First things first, start your modules with a full complement of Dunder future imports. You'll probably wind up writing these so often that you just learn them off by heart. Certainly I can bash them out off the top of my head without even thinking these days. What do each of these actually mean? Unicode Literals. This is the major change in Python 3 compared to Python 2, that bare strings with no prefixes, U, B, whatever, are now Unicode. So if we take the type of a string in Python 2, you can see there at the top, that's a Unicode string. In Python 3, this is what's at the bottom here, you can see that the type of a bare string is now str. But in Python 3, str is the Unicode type. This is where it gets slightly confusing. The type of a byte string, that's a new thing introduced in, I think, Python 2.6 or 2.7, and certainly present in Python 3. That string's prefixed with a B is type str, which is byte string in Python 2, and type byte in Python 3. We'll come back to how we can sort out the confusion between these types, especially reassigning str a bit later on. But basically, this Dunder feature import will mean that any string that you declare will be a Unicode string. If you want a byte string out of it, you'll need to explicitly call encode on it. Next, absolute imports. Bit of a hairy one, this. To be honest, if you're not writing packages, you probably don't need to worry about this one. How do you know if you're writing a package? If you have a dunder init.py file in your path, in your directory with the rest of your modules, you're writing a package and you need to worry about this. Absolute imports are the standard under Python 3, and it basically means that any import that you do that isn't prefixed with dots is absolute and must be findable from somewhere in sys.path. So, for example, there we've got import foo, and that means that foo.py must be present in one of the directories listed in sys.path. If you want to import something from a package in the same directory as the current module, simply prefix the module name with dot. So if foo.py is in this module's directory and we want to import it, you need to do import.foo. If you don't do that, you'd have to import package name.foo explicitly, so it would be an absolute import. And we can extend that with .foo for the parent module's directory and .foo for the parent module, and so on and so on and so forth. So that's absolute imports. But as I say, if you're not writing packages, if you don't have a dunder init.py, you probably don't need to worry about this.
Dave, did you see the question from Greg in the...
I'm in a subdirectory and I want to import. Yeah, you can't do /.foo. If you want to go up one directory, it will be .foo. If you want to go up two directories, it would be .foo, and so on and so on. So if there are no slashes in imports, it's simply count of dots that dictates which directory you're looking at. So that's absolute imports, and as I say, that's the standard in Python 3. Print function. Another major syntactically, but not terribly interesting change. Print is now a function, it's not a statement, so any prints that you have, surround them by parentheses. For the most part, if you're just doing bare prints and you're not using anything weird like redirects, this is not a major change. You just wind up sticking parentheses around all your print calls and off you go. Why change print to a function? Well, as we'll see a little later on, the old print statement has some pretty weird things in it. And also this means you can use print in places like lambda. Occasionally that's useful. Anyway, that's print function. And finally we come to division. Division is an interesting one in Python 2. Most people think that division in Python 2 is integer division. It's not. It's floor integer division. So as you can see at the top there, if you do 1 over 2, you get 0. If you do -1 over 2, you get -1. Well, From done to future import division makes division like Python 3. That means the division operator becomes floating point. So 1 over 2, 0.5, minus 1 over 2, minus 0.5. And it introduces a new operator, double slash, for the original Python 2 floor division. So as you can see, 1 double slash 2, 0, minus 1 double slash 2, minus 1. Generally worthwhile doing. If you include that, just grep through the unit for any slashes, check if they're a division, adjust accordingly. So there's our full complement of done to future imports. What about this whole str bytes nonsense, where str is one thing in Python 2 and something completely different in Python 3? Can we fix that? Well, here's a horrid, horrid, dirty hack of my own devising that you can see at the bottom there. Str equals type blank string. People that know Python will rightly raise an eyebrow at this and go, what on earth are you doing there? This is basically an attempt to make str mean the same thing across Python 2 and Python 3. In Python 3, this will do absolutely nothing. In Python 2, after you've imported Unicode Literals, this will reassign str to mean Unicode. What this means is that we can then use isInstance exactly the same way consistently in Python 2 and 3. So we can ask for isInstance of a string, check if it's true, and it comes back true. IsInstance of a string as bytes, false. And likewise for byte strings, b prefix, we can test them for str or bytes, and they come back the same. So this is a dirty little hack, but it is quite useful, and I wind up using it fairly commonly in my modules that just sorts out that discrepancy between str and in Python 2 and 3. Occasionally, you will come across nasty modules. One of these is Struct. Struct is a horribly, horribly nasty module. It's very useful for packing and unpacking bytes. But the problem with Struct is that the format string in Python 2 must be a byte string. It won't accept a Unicode string. And the format string in Python 3 must be a Unicode string. It won't accept a byte string. So what the hell do you do? If you're using the little hack earlier of str equals type blank string, you need to first capture whatever the native string type is. I usually use nstr or native str or something like that. And then in the struct.pack where you've got the format, you use nstr of whatever format, and that should work in both Python 2 and 3. It's a bit of a painful, horrid hack, but thankfully it's something fairly rare. There are a couple of other places in the standard library where this happens. I can't remember that off the top of my head, but Struct is the one I keep running across. So whenever I use Struct, it's back up to the top of the module and add the instr. I/O. Most people who are dealing with files in Python probably just use bare open. Bad idea. Fine in Python 3, but bad idea if you're trying to write idiomatic Python 3 in Python 2. The I/O module is your friend here. This is something I think was either introduced in 2.6 or 2.7. In Python 3, it doesn't do much. In Python 3, io.open is the same as open. In Python 2, io.open is exactly the same as io.open in Python 3. So if you... Oh, yeah.
There was a question previously, so
Sure.
sorry to interrupt you, but
Go ahead, yeah.
there's a question from Greg. When the struct hack, when to detect, what's the earliest reliable way to detect when we need to do the struct hack? So the previous.
The earliest reliable way, simply as soon as I use struct, the second I import struct, I'm back up to the top of the unit and I do nstr equals str. As we go through this, you'll see various places where there are certain keywords where you think, okay, now I need to add something to my compatibility imports at the top. So as soon as I come across struct, I add that compatibility import. Generally speaking, how do you know you should be doing this? Well, in struct, because I've told you. In other cases, as I say, there's a couple of other minor cases in the standard lib where this comes up. I generally get notified of this because I test all my code on Python 2 and 3. So every time I commit, tests get run, and then something fails on Python 2 or 3, and I know I've got a problem. If you're not testing your code, well, you should be testing your code. It's basically a matter of running across it when you can and knowing when to do it. But as I say, Struct just keeps on coming up for me. It's one of those libraries that I use an awful lot, so I just know as soon as I do it, it's time to use Enstra. I'm afraid that's about as much as I can offer in terms of advice on that one. So yeah, back to I/O. I/O is your friend. I/O will basically make Python 2 I/O compatible with Python 3. IO.open has a few differences in Python 3. It now accepts an encoding attribute, or parameter, which specifies the encoding of text files. So if you're opening a file without the B mode, if you're just using W or R instead of WB and RB, then you probably want to specify an encoding. The default's ASCII, I think. You probably want to deal with something more sensible like UTF-8 or ISO 885915, something like that. Whatever encoding you've got, you specify it there, and it will return you Unicode strings when you read, and when you write, it expects Unicode strings. So if you're writing to that file at the top there with io.open foo.text, it will expect a Unicode string. You cannot pass it bytes. Same as in Python 3. The binary file we've got below there, io.open, and we've got the mode RB. That will expect byte strings when you're writing to it, hence the B prefix on the string there. When you read it, you will get back byte strings, and thus if you want Unicode strings from them, you will need to decode them. You probably have run across some things like string I/O as well. String I/O is a fairly common thing that's used for creating in-memory streams. Well, string I/O is deprecated in Python 3. What you want to use instead is, again, the I/O module, which has a couple of classes, bytes I/O and string I/O. String I/O in I/O, io.string I/O, is subtly different from the string I/O module in Python 2, in that, as the name suggests, it only accepts strings, Unicode strings specifically. So io.string I/O is fairly rarely used, because if you just want strings in memory, why not just use strings? Bytes I/O is the major one that you'll probably wind up using when you want an in-memory binary stream. io.bytes I/O is a binary stream, like a file opened with mode RB or WB, so it reads bytes and expects byte strings on write. Hence the example there of writing 2 bytes of FF. So, what have we got? Any questions? Travis things. Right, so that's bytes I/O and file I/O. Basically use the I/O unit, and your I/O will be exactly the same in Python 2 and 3. So, zip, common function for zipping together sequences. Generally speaking, you don't need to worry about this. If you're zipping together 100 items, 500 items, who cares? The zip in Python 2 will manifest that entire list. Doesn't matter. That's small enough that it's not going to make any difference to the performance of your particular script. But if you get into zipping very large sequences, let's say you're zipping 100,000 things, well, then you probably want the iterable zip. This is the standard zip in Python 3. Iterable zip in Python 2 is from itertools, import izip, and here we're importing it as zip, so we're overwriting the built-in zip so that we can write idiomatic Python 3. As I say, you only need to worry about this if you're zipping a very, very long sequence, or potentially zipping a long sequence. And if you do, well, as soon as you use zip and you think that's going to be a big sequence, pop back to the top of your unit, stick that at the top there as a compatibility import next to your dunder future imports, and off you go. Similar story for range. Again, if you need range 10, range 20, don't bother, just use range. Sure, it returns a sequence in Python 2, so what? It's small enough it's not going to make any difference to the performance of your script. But if you potentially need a big range, 100,000, a million, well, time to go and look at xrange. Range in Python 3 is actually substantially better than xrange, so this is not an entirely compatible way of doing things, but it's close enough for the vast majority of purposes. So as soon as you use range in your module and you think that's going to be a really big range potentially, hop back to the top next to those dunder future imports and stick in this. Try range equals xrange. In the name error, don't do anything. This will make range effectively close to the Python 3 range. I may come back to exactly what the Python 3 range has additionally in a little bit. Reduce. This was one of the weird changes in Python 3. I'm not entirely sure why they did this. Guido has a thing about reduce. Basically, reduce was removed from the built-in namespace and placed in the functools namespace. As a compatibility SOP in Python 2.7, there is a transparent shim in functools for reduce. So you can run, if you use reduce in your module, pung this in your imports from functools import reduce. It'll work just fine in Python 2.7, where it basically won't do anything, and in Python 3, it'll import reduce. So that's a fairly simple one. The more tricky one is the modules in the standard library that got renamed. Most of the modules that you use in the standard library have lowercase names, IO, OS, sys, FN, match, glob. No problem with those. But there are the odd one like socket server here that in Python 2 used camel case. And in Python 3, these were fixed for PEP8 compatibility with lowercase versions. So if you find yourself using one of these, I'm afraid you're in for a bit of pain. When you import it, you'll need to import it in such a way that it works in both. So top example here, if we're doing from socket server, we import a couple of things, TCP server, forking mixin. If there's an import error, we use the Python 3 name. General rule of thumb here, put the Python 2 one in the try, put the Python 3 one in the accept. We'll see why in a little bit. If you're just importing the bare module, alias it to the Python 3 name, so we've got import socket server as lowercase socket server here, except import socket server. So, that's a way of getting the modules working more or less consistently across Python 2 and 3. I'm afraid it is a bit ugly, but, well, it's all at the top of the module, and the main body of the module is still hopefully idiomatic Python 3. So hang on a minute. Are we saying that the top of our module is going to wind up looking like that? Enormous mess of compatibility imports? Well, partially, not entirely. As we've seen in most of these try-except imports, there's usually a Python 2 branch and a Python 3 branch, so be smart, consolidate. As soon as you know you're in Python 2, stick all your try stuff for Python 2 at the top, stick all your Python 3 stuff at the bottom. The idea here is we want to be writing idiomatic Python 3 in the body of the module, and we want all our compatibility imports consolidated at the top so that in the far-flung, dim and distant future when Python 2 is but a fading memory and nobody cares about it anymore, and we want to convert our code to beautifully pristine, clean Python 3, all we have to do is go to the top of our module, select all that Python 2 stuff, and then delete it. At that point, okay, unindent Python 3 bit, you're more or less good to go. So we've been talking about things that we should be doing for Python 2 compatibility with Python 3. What about things that we shouldn't be doing? What should we not be touching? As mentioned previously, raw opens, convert those to io.open. If you're using string IO, convert that to io.bytes.io. And dictionaries have these very commonly used methods in Python 2, iter items, iter keys, iter values, so on and so forth. More or less the same story as with zip and range earlier. If your dictionary is not huge, don't bother with it. Just use items, just use keys, just use values. Sure, it'll manifest the whole list. I don't care. It's 10 items, it's 20 items. It's not worth, it's not going to make any difference to the performance of your script. And then it'll be compatible with Python 3. If you've got a dict of 1,000,000 items, well, I'm afraid you're in for a bit of pain then. In that case, you're probably going to have to put, if we're in Python 2, do this, else if we're in Python 3, do the other. One thing that's worth noting is that Python 2.7 introduced completely compatible versions of items, keys, and values of the different names to Python 3, which are view items, view keys, and view values. Iter items just returns an iterable. You can't modify that iterable, and view items returns a mutable view over the dictionary itself. Whether you actually want to mutate it, different matter. But so your code should wind up looking like that in the general case. io.open stream equals io.bytes.io, and we should be using dictionary.items, not iter items. unless it's huge. Print statements. As discussed earlier, there's the print statement, print hello world. We want to be putting parentheses around that. How many people knew the bizarre C++ inspired redirect format that you had in the old print statement? It's such a weird thing. This was one of the major things about Python 3. It wasn't just about cleaning up some parts of the language like Unicode Literals. It was about removing legacy nonsense like this, where all of a sudden you've got sort of half C++ in the middle of your module. What should this look like in Python 3, or after you've done the dunder import print function, how should we do a similar redirect? It's now just an argument to the print function, file equals sys.standard. So much, much easier. And parentheses around the first print there as well. Nice and simple. If you're using classes, always declare the parent of the class. If you don't do this in Python 3, well, no big deal, but in Python 2 there is a big deal. In Python 2, if you don't declare the parent of a class, you've got an old-style class. Old-style classes are subtly different to new-style classes. They can't use properties. Super doesn't work in them. It's all a bit of a mess, really, and this was yet another thing removed from Python 3, thank goodness. Unfortunately, there are a couple of places in the standard library that still use old-style classes. Hopefully that won't cause you too much pain. Has occasionally for me, but it's nothing you can't work around. So what should this look like? Well, we ought to have a parent after my class there, and then down in the init you can see something that won't actually work in Python 2, a supercall with just bare parentheses. This is something you can do in Python 3, and if you jump to Python 3, well, good for you, okay, but if you want to rewrite in code that's compatible with Python 2 for the time being, you need to use the long form of super, which is class and then instance as arguments. So what should this look like? We've got the parent class there, after my class, and we've got in the supercall my class and self, class and instance. That will work perfectly well in both Python 2 and Python 3. Except clauses in try statements. Subtly different. We have a horrible mess in Python 2 in as much as the old style way of doing it, where you can see there, except zero division error, comma E, where E is used to capture the exception variable. However, you can also do a list of exceptions in the except clause. How does it tell the difference between those? Well, the bottom one there won't work properly. It will wind up storing the instance of a value error in the variable IO error. Obviously not what's intended. Python 3 and backported to Python 2.7 introduces a new syntax for dealing with this. Instead of comma E, you use as E. And then if you have a list of exceptions, it absolutely must be parenthesized. So what should this look like? Except zero division error, as E, and that list of exceptions at the bottom there, parenthesized, and we don't want to capture it, so we haven't specified an as in that particular case. So, what else have we got? How many people knew you could just raise a string? You can't in Python 2.7, actually. I think in 2.6, possibly in earlier versions, you could. This is a hangover from Python 1, where you could raise string exceptions. They're nasty things, and you never want to use them, and this is removed entirely. As I say, this won't even work in Python 2.7, so no, don't do this. If you find it in your code, replace it with an actual exception call, such as raise exception. What about stuff that's only in Python 3? Well, there's plenty of new toys to play with. We can see at the top there we've got an example of multiple value unpacking. So in that particular line, A would be 1, C would be 5, and B would be everything in the middle. Next, we've got an example of keyword-only arguments. So foo and bar in that function f there can only be specified as keyword arguments. They can't be specified positionally. And then you've got the new X mode there in io.open. X meaning create only if it doesn't exist, raise an error otherwise. And of course, lots of new modules in Python 3. We've got isClose in math. Very, very useful for checking floating point numbers, and the statistics module. And in 3.5, you've now got the matrix multiplication infix parameter, the @ symbol. Well, basically, if you're not fully migrated to Python 3, you don't get to play with the new toys. When you fully migrated to Python 3, then you get to play with the new toys. And that's about the end of it. That's about all the advice I've got to give for writing idiomatic Python 3 in Python 2 interpreter. If anybody wants, we can go and have a trawl through a particular module. We can have a look at a few libraries I've written that work in both of them. Otherwise, that's me. Again, if you want to contact me offline about any migration issues, do feel free to do so. If you want to have a look at the GitHub, there's several libraries on there that use most of these tricks. So they work in Python 2 and 3. And otherwise, thank you. Any questions?
There's a couple of questions on
Right. We've got questions on Etherpad. Okay.
So one was, can you sensibly use an if statement to tell, if Python 2
Do the imports, yeah.
Right, okay. Can we use if statements to determine between the two of them? Yes, we can. Actually, let's go and have a look at an example library. Let's go and have a look at and I'll bring that up here as well so people can see it over here.
We can see your screen because everybody's in here.
Ah, well, just in case. So. Right, let's go see PyCraft. This is actually a library for interfacing with Minecraft on the Raspberry Pi and various other platforms. And it's got several tricks in it for working with both Python 2 and 3. If we want to see an example, this is actually one of the rare cases I came across where Python 2's range, or X range, was insufficient for emulating Python 3. Most of the time, you just want range to count off numbers, and for that, X range is absolutely fine. However, in this particular case, I wanted to make a three-dimensional vector range, and that meant I needed a range that could return any arbitrary value within it, which could search for values within it. And the Python 3 range will do that in order 1 time, which is very, very nice indeed. Python 2's X range won't. When you search in it, it's order n time. Horrible. So, I wound up writing a pure Python version of range for backporting to Python 2. And we can see that in order to ensure that it doesn't appear in Python 3.3 and above, there we've imported sys and gone if sys.versioninfo is greater than, is less than 3.3. Let's just make that a bit bigger so people can read it a bit more easily. Hopefully that's a bit better. So we've got if sys.versioninfo less than 3.3 specifically in this case. Python 3.2's range was also rather crap. It doesn't include start, stop, step. It doesn't include order 1 searching, so on and so forth. So this was me basically rewriting the whole of range specifically for Python 2. This is the only time I've had to do that, though. Normally, X range is fine for the vast majority of purposes for emulation. And as I say, if you're not dealing with big ranges, don't even bother with X range. Just use range normally. It's fine. So what if it manifests the list of 10 items? That's trivial. Really doesn't matter. Let's have a look at a couple of other modules in here. Let's go have a look at vector. And then we can see some more examples of writing idiomatic 3 and 2. So we'll copyright gump and a load of documentation stuff. And then, oh look, the dunder feature imports and a struct type from compound import range. My rewritten range implementation. And down here we can see I've wound up having to use zip longlist somewhere. So I wound up importing izip longlist as zip longlist. All the rest of the imports exactly the same. I haven't really followed my own advice there and done Python 2 as the try one instead of Python 3. I should probably switch that. But other than that, in the rest of the code, once those compatibility imports are done, the rest of the code is just idiomatic Python 3. I haven't used ifs anywhere. The rest of it just runs quite happily in Python 2 and 3.
So I think the question was specifically about the compatibility imports at the top.
Right.
Whether you would think it's better to try or to?
Generally speaking, when it comes to compatibility imports to the top, I try and use terms that will work in both Python 2 and 3 transparently without introducing ifs, because then I don't have to import sys at the top. What I really want is a block that later on I can just delete. And that's why the from future, that does nothing in Python 3, so you can just delete it later, that's fine. The story equals type hack, that again, you can just delete it, works transparently in both. Sometimes you may find yourself having to use an if there. It's ugly, but generally speaking, I find the try excepts work perfectly well, and they're probably a better way of going about it, simply because, again, you're not importing sys, you're not using an if, and if there are cases of things that appeared later in, let's say, Python 3.4 or something, and then not in Python 2, or not in an earlier version of 3, the try except will basically pick all that up. You're not having to figure out exactly which version did this come about in. So yeah, I generally favour the try except model. Easy to ask for forgiveness than permission, I believe, is the idiom, EAFB. I think it's generally a better way, but yeah, you may wind up having to use ifs. Hopefully not, but if you do, sys.versioninfo is the thing you want. It's a tuple of all the parameters, and because tuples are orderable, you can just do what we saw earlier if sys.versioninfo is less than 3,3. That will tell you if you're below Python 3.3 or not. But generally, I try and avoid that stuff. So, what other questions have we got?
Sort of getting mixed up with other things.
Comments on writing C extensions for 3. If you're writing C extensions for 3, I'm afraid you're in for a certain amount of pain. There are a few differences in the API, but there is an ifdef, there is defined that you can rely on for doing ifdefs, and the standard seems to be that whenever somebody comes across a difference in the API, they throw in an ifdef at that particular point. The changes are relatively minimal. As far as I know, it's a couple of renames. When you're declaring the module, I think you have to declare a struct, whereas you didn't in Python 2. I can't quite remember off the top of my head. I'm wondering if I find any examples of that quickly. I haven't written any of myself, but basically the standard seems to be ifdefs, and I'm afraid that basically means you just need to learn the differences between the APIs. I think somebody also commented earlier that this does make it harder to teach newbies Python 3. That may be the case right now. I can tell you that in a few years it won't be the case. Schools almost exclusively have switched over to teaching Python 3 entirely now. So a few years down the line, you're going to wind up with new intakes that only know Python 3 as a rule and don't know Python 2, which is another reason for migrating. But it probably will be true for the next few years, I'm afraid.
So there's another question. What about the 6 module?
6 module.
What is the 6 module? I mean,
yeah, 6 was a project that tried to do more or less this, bridge the gap between Python 2 and 3, so it provides a load of compatibility imports. It's one way of doing it. My slight objection to it, it's a good option in some cases, but my major objection is that it's another thing that if you were writing pure Python 3, you wouldn't use. And you tend to wind up sticking its imports in amongst your normal imports. What I'm trying to aim for in most of my modules is a block of compatibility at the top. And you could argue, well, you stick the 6 stuff up there. But then you may wind up with imports of its compatibility versions of socket server and such like that ought to go in the main body. So it's yet another thing that you'd have to remove come time to migrate. Personally, I haven't used it relatively extensively. I tried it on a couple of early ones and then went, well, most of this stuff I can make work without 6 quite happily. There's probably a couple of cases, I think, dictionaries that might be worth using for 6 if you have massive dictionaries where you absolutely need to use iter items or view items. Other than that, I think you can get by pretty well without it, but it may be worth a look. I think we're more or less coming up to the end of the time now. Probably squeeze in one more question, possibly.
So the only other question on the list is from Anthony, who asks, what is the best way to cope with raw input and input.
Raw input and input. Oh, sorry, I did miss that one out, actually. Exactly the same way that we dealt with most of the other ones. If you find yourself having to use input, try input equals raw input, except name error, pass. So just another try except compatibility statement. You can shove that with all the other compatibility things at the top. And yeah, just a straight try input equals raw input. That will fail, obviously, on Python 3 with a name error, because Python 3 doesn't have raw input. So just a try except, and you're done, on your way.
And what about the parameters the same?
Yes, raw input is literally input on Python 3. So as soon as you've done that, you will then have input exactly the same in Python 2 as it is in Python 3. So that simple try, input equals raw input, except name error, pass. That will do for input entirely. Yeah, I think that's about the end of our time. So we probably ought to yield the floor to the next person. Yeah, thank you very much.
Thanks.
Right, now online.
Thank you. Okay,
Right.
so switch to Greg, and I'm going to deal with that setup there.
I can see it. Yeah.
Right, I'll just
Working.
stop the broadcast here and this particular one.